Hello Hoptown students, this is Mr. Martin, and today we're going to talk about our last exponential property, which is called the power of a power rule. This is essentially you're raising a base to an exponent, and that's being raised to another exponent. So you have two exponents basically in this problem right next to each other. And first things first, we're going to write our target today, and our target is I can simplify exponential expressions using the power of a power rule. You want to underline power of a power rule because this is different than our quotient product and other rules we've talked about this week. You can pause it right now, or you can wait till I'm done with this slide, or you can watch the video, but you need to write down this target. First thing we're going to do though is the power of power proof. In other words, what is it we're really doing when we do the shortcut that we're going to discover in a second? Well, we need an example problem first. So our example problem, once again, I'm going to use a variable as my base, and it's x to the second power. But that is being raised to the fifth power. So it's two powers colliding with each other. Well, the first thing we've got to do is how to interpret this problem. And there's different ways to interpret it, but one way is we take our outer exponent, because it's saying that we're raising what's inside the x squared, which means that we have 5 of these x squares in a problem. And since this is being raised to the fifth power, that means each of these x squares we are multiplying to each other. Well, we've just turned this into the product rule. And if we remember our product rule, as long as our bases were the same, we could add our exponents. So 2 plus 2 plus 2 plus 2 plus 2 is really x to the 10th power, which means our answer up here has to also be x to the 10th power. Now, some of you who have paid attention to the product rule and the quotient rule proofs probably can already see what you're going to be doing here. I'm going to do one extra thing to make sure everybody's along. What this also means is we have these x squares, and we can expand them out into how many real x's we have. And here's the last of the x squares. So if we look at this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we still have x to the 10th power. Now, if you really look at this, what can we do for 2 and 5 that will give us 10? And a lot of you have already said multiplication. You've already thought it probably as soon as that x to the 10th power came up. Well, that's essentially the rule for the power of a power rule. If you're raising if something's being raised to a power and that whole thing is being raised to another power, you can multiply your two exponents together and keep the base, and you'll have the simplified version of that base and exponent. So let's take a look at this real quick and see what the power of a power rule really states. Forgive the bell, it's on automatic. I can't stop it, but that'll be the last one for this video. So if you're raising a power to an exponent, or you can say a power to a power, or an exponent to an exponent, you multiply your two exponents together. So if you have x to the n power, and that here is being raised to the n power, that means what you can do to find out what exponent should really be on the x is multiply your two exponents and keep your base. So that's basically this rule in a nutshell. So if we look at a simple problem even with a numeral as our base, if we have 5 to the third power and we're raising all of that inside to the second power, you don't have to go through the whole process of raising and raising and raising again to find out what that could be. One thing you could do is go ahead, keep your base, multiply your exponents together, and see what you're really raising that to. And if you don't want to do essentially 125 and then multiply 125 by itself, you could go over here and say, oh, I'd rather just multiply 5, keep multiplying 5 because it's easier on me. But this is a shortcut to get around a problem. So, when I take a power to a power, I multiply the exponents. Okay? You need to get down what's up here, and especially this right here, because this is just almost like repeating what this is saying up here. If you want to get down to this sample problem, you can, because it's another sample problem that can help you understand what we're doing. You may pause the video to do that if you wish. What we're going to do now is we're going to try out a few problems here. And these problems do get increasingly difficult. So let's start with an easy problem, something that we just kind of saw. We have 3, it's the second power. Now some people would probably go ahead and say, I'm going to raise that to 9. I'm going to go ahead and raise it and make it 9. You can do that. I mean, that's not a problem, but sometimes multiple choice answers won't have 9 to some power. Sometimes they're going to leave you at 3. So let's go ahead and leave the 3 alone. We're going to leave that as our base. And we're raising the second power, and that's being raised to the 5th power. Well, we multiply our exponents together, and we'll know what we're really raising 3 to. And in this case, 2 times 5 is 10. So that's kind of an example problem that we've already seen, basically. So let's look at number 2, because number 2, you notice there's a negative exponent that pops up. So is anything going to change here? Well, the rule stays the same. So we're going to keep our a. We know it's being raised to the 3rd power, but that's being raised to the negative 4 power. So it's going to be a to something, but 3 times a negative 4 is negative 12, which once again, we have a negative exponent. What do we have to do to it? Well, we got to make it positive, and the way you make it positive is throw it into the denominator. And when you do that, you have simplified and said what this really is. It's at 1 over a to the 12th power. Let's look at number 3. Now, number 3, we've got 2 bases. We have 2, which is just a 2. And if it's just a number, if it's just a variable, what exponent does it get? A 1. I lied. It's still raining. Anyway, so what we're going to do this time, we got 2 different bases, but they're both being raised to the 3rd power. Well, this is where your distributive property comes in. We have parentheses here, and since we're going to multiply this to our 2 exponents, we're going to distribute the 3 to our 2nd power, and we're going to also distribute it to our 1st power on the 2. So really what we have is 2 to the 1st power times 3, and then we'll have a to the 2nd power times 3. And so our 2 is really to the 3rd power, and our a is really to the 6th power. Now that is an exponential form, but sometimes people will want you can't do anything to a, because we don't know what it is, but sometimes they will want you to raise the 2 to the power it's given, because we can do that. So just in case, remember, 2 to the 3rd power is 3 2's in a multiplication problem. If you did that, your answer would be 8, and then we just stick on a to the 6th power because we can't do anything to it. It just depends what's in your multiple choice answers on, for example, a K-Prep test, or the Discovery test, that online test you took about over a month ago. So most likely they may want you to have that as your answer, so just keep that in mind. Here's a little bit longer, a little bit more complex problem, but it's more like this problem here where we have all these exponents on the inside, and this time we have exponents everywhere on the inside. But it's all being raised to the 2nd power. That means we're going to multiply this 2 to our exponent, 1st exponent, our 2nd exponent, and our 3rd exponent. So we're going to have 2 to the 2nd power times another 2nd power, a to the 5th power, but we'll raise that to the 2nd power, and then b to the third power times the second power, since we're raising it to another power. So this time we're going to have 2 to the 4th power, a to the 10th power, and b to the 6th power. And like I said, sometimes they want you to raise this 2 to the 4th power to really what it is. Well, we already know that 2 to the 3rd power is 8, so we multiply that by another 2. Our answer here would actually be 16. So they could show you 16a to the 10th power, b to the 6th power. You just need to look at your multiple choices and see if they want you to raise that. You could look at your a and b and just match up your finding with the 4 multiple choice options, and then think about for a second, well, my A10, B10 matches with these. 2 to the 4th power has to be one of those coefficients in front of it. Let's look at our last example here. We have s to the 2nd power, t to the 4th power, but all that's being raised to the negative 3 power. Same rule applies. We're going to distribute this negative 3 through. So we have s to the 2nd power times negative 3, since we're raising to the negative 3 power, t to the 4th power, but we're raising that to also to the negative 3 power. There we go, I'll make it a little bigger. So what's that really mean? Well, s 2 times negative 3 is really being raised to the negative 6 power. T is being raised to the 4 times negative 3, negative 12th power. But since both of these have negative exponents on them, we're going to go ahead and turn this into a fraction. We're going to dump these in the denominator and remove the negatives off the exponents. So here's our answer. S to the 6th power, t to the 12th power. Each question got a little bit more difficult because of all the negatives, and plus if there's multiple terms in the problem, or multiple factors, my mistake, multiple factors in the problem.